Last but not least, no pressure on you, Neville, at all. Neville is the VP of Business Development for Qualcomm and is going to talk about all kinds of things related to LTE-based technologies. And the floor is all yours.
Thank you.
Clock, done.
Thanks. I'm going to make it short and sweet. I'm going to talk about MulteFire, which we believe is basically a new way to wireless. If you think about MulteFire taking the best of LTE and the simplicity in terms of the deployment of Wi-Fi, then you have MulteFire. And with MulteFire, we will walk through a number of new examples of the types of business that we believe that this new technology can support. This new technology is built around LTE, and I'll describe that in a moment. But really, it's aimed at smaller types of installations. So it's not a replacement for a wide area network. It doesn't compete with LoRa or Sigfox, but it certainly is a new way to think about getting into enterprises and to installations like factories and warehouses. So MulteFire is actually built upon 3GPP standards. It leverages release 13 and release 14, LAA, which is essentially the aggregation of licensed spectrum with 5 gigahertz unlicensed spectrum, and ELAA, which is essentially the uplink configuration that is supported now within 3GPP. And essentially what we've done is we've taken LAA and ELA and we've taken away the licensed spectrum, and so now LTE can run in 5 gigahertz. It also can run in 2.4 gigahertz, and we're looking at the potential for it to operate in 800 and 900 megahertz as well. All of these bands are essentially unlicensed spectral bands. And as of Monday, you will be able to go to the multefire.org website and download the specification for MulteFire. So the specification was completed in January and will be made public on Monday. And so a number of chipset manufacturers, eNote B manufacturers, and anybody who wants to leverage the technology can actually start looking at the specification come Monday. When you think about MulteFire, think of it in two ways. Firstly, you can create these private networks that allow you to actually run a network within a specific area, much like a Wi-Fi LAN network. Or MulteFire can actually supplement what the mobile network operators are doing if they don't have enough spectrum. And so they can leverage MulteFire on a wide area basis as well, in areas where they want additional hotspots. Where I'm going to focus today is really around these new deployment scenarios where we can actually have this controlled environment within a factory, for example. Here, what we can do is actually tailor MulteFire for the specific use cases of the enterprise or the factory. So we can do things like predictable latency. We can do things like quality of service. We can build the network so that we have extensive coverage and capacity. And we can support that network with a number of different IoT installations that we'll go through. The other thing that we can do, which is really interesting, is we can actually have a wide area fallback. So not only can we support the local area network, but if a truck, for example, moves out of the environment into the wide area, we can track that with a business relationship with an MVNO agreement. We can also support neutral host environments, and that means that if Verizon, AT&T, Sprint, et cetera, want their devices to work in this private IoT environment or private network, they can allow that as well. It's really a business relationship. The technology is there today to facilitate it. So if we look at the advantages of why we believe MulteFire is really going to disrupt the market on a global basis, you've got to look at what the properties of LTE are. So better capacity, so we can actually have multiple number of devices on the uplink side in the network. Unlike Wi-Fi, we actually perform a lot better on the uplink. We have better coverage. So in tests that we've done, we have 2 to 3 times the coverage of a standard a Wi-Fi network at 5 gigahertz. We have seamless mobility, so if you go across to the MulteFire stand there, we're actually demonstrating seamless mobility handoff between MulteFire devices. Industry-grade reliability, so we support quality of service. That means if you want to give a higher quality of service to one device over another, we can do that in this local network. We have LTE-based security, so either SIM-based or SIM-less-based security. We leverage that platform. There's no change there. And we're future-proof. In other words, what MulteFire today is working towards is a 5G future where we can take advantage of millimeter wave, ultra-low latency, high predictive reliability as well. And so 5G NRSS is really what we call MulteFire 2.0. It's the future of what MulteFire will look like in 4 or 5 years' time. From a network perspective, it's a very simple architecture. We basically build the network on site, and we can control the network. In other words, the management plane sits in the cloud. And in this way, it's actually very, very scalable. We can have multiple instantiations of the network at anybody's premise. It's private, the data is private, and we can support that through a single cloud architecture. We can also support various types of devices. So a edge sensor type gateway device that will support multiple additional radio technologies like Wi-Fi or Zigbee or Bluetooth. We can support augmented reality in the network. We can support communication protocols, so we can support ruggedized tablets or handsets, and we can support cameras. So the difference between, you think about this network and any other type of network is, not only can we do very, very low data rates, but we can actually support very, very high data rates. And as we go through these use cases now, you'll see why that's really important. So the first use case that we're going to look at is in an airport. And this is really not the inside of the airport. This is basically providing connectivity for outside an airport. In other words, bringing connectivity to the planes, bringing connectivity to the ground staff, to all of the systems that they have, baggage handling, refueling. Today, there isn't sufficient capacity in the network to support this. One of the engine manufacturers that we're working with generates gigabytes of data in each engine per flight. And in order to suck that data out of the plane on a wireless network is extremely challenging. And really, we believe that this type of bespoke private IoT network is going to allow us to change the way these types of devices actually communicate and upload their data. There's also the advantage of, if you have this network, being able to push entertainment back into the aircraft. And so you can actually have two-way communication coming from the aircraft and going into the aircraft as well as connecting all of the systems on the ground. The same is true in a port. So we're actually working with a major port in the US who wants to deploy a private IoT network. We're working with a major partner who is doing the data optimization within the port. And again, with this private IoT network that can be deployed specifically for that port operator, we can support communication protocols as well as multiple IoT devices, whether it's gateways, security cameras, cameras that are used with edge analytics to count the containers or to manage traffic flow. All of these types of systems can actually be deployed in order to increase the turnaround and make the port more efficient. The third example is within a factory where you actually deploy a bespoke network, again, for the purposes of connecting large machines. Again, these machines are generating lots of data that needs to be collected and analyzed by companies such as GE through their Predix network in order to make them more efficient and more operational. So we worked with Harbor Research across over the last 9 months, and we looked at all of the different segments that are out there. and we took the differentiators that MulteFire, as well as LTE, TDD, and 3.5 here in the US, we looked at those differentiators and we said, if we had to put those differentiators through a filter, what market segments would be interested in this type of technology? And we came up with 15 segments. These are the 15 segments that we identified. It's segments where essentially large-scale data can be pulled together in order to make the environment a lot more efficient and to do things like preventative maintenance. We are part of an alliance, so MulteFire is an alliance of a number of different companies around the world, large infrastructure vendors. As you can see here, we have a couple of operators as well, including SoftBank. We believe that the technology is, as built on LTE, really a platform for driving private IoT networks forward. We would love for you, if you would like to find out more, please visit us at the booth or speak to me after this talk or go onto our website, which is the CBRS Alliance website. So lastly, in summary, MulteFire takes the best of LTE, the best of Wi-Fi, puts it together, and allows easy deployment. It has all the traits of LTE, which give it a huge advantage in terms of scalability and performance. It supports neutral host environments as well as single operator environments, and it supports this new type of business model that we're going to see in the next few years emerge for private IoT networks built on an LTE-based cellular technology. Thank you.
So,
any questions? Yeah.
Anybody have any questions? Okay, I do. All right, I do. So, revenue model. So you're selling the entire system? Are you operating the system? How does that work?
So there are companies already that have already announced that they want to offer these services to IoT networks. Nokia, GE, and Qualcomm actually made an announcement at Mobile World Congress that we're collaborating together. Huawei has already put deals together and announced that they're going to be operating these services as well. So there are a number of companies that are emerging that really see this part of the market as a new opportunity, new way to actually do wireless connectivity.
And so from a solutions provider standpoint, how does a solution provider with an app for shipping, dock, asset tracking get involved with MulteFire?
So for example, we have already integrated with Predix, and so that app can run on the Predix platform and be part of their communication and analytics environment.
Got it. Excellent. Well, we got a question back there. Sir, you're going to have to stand up or come to the mic or yell it out, which I have a feeling you know how to do. What's it? LTE-U and the differentiation?
So LTE-U is a early variant of LAA. So LAA, you require licensed spectrum. With MulteFire and with running LTE TDD in the GA band here in the US, you don't require licensed spectrum. So the advantage is that anybody can deploy MulteFire. As long as you have a great application for it, you can deploy it. You don't have to have licensed spectrum.
Frequency range.
So right now, so the 5 gigahertz band, so the same band that Wi-Fi operates in, MulteFire will be in the next version support 2.4 gigahertz as well. And then lastly, we're looking at whether we should put MulteFire into 800 or 900 megahertz as well.
What was that again?
So MulteFire is built on the same principles as LAA, which is listen before talk. So with listen before talk, it will basically coexist perfectly with Wi-Fi. But remember that in a private IoT setting like this, or a setting like a factory, often what the IT manager does is segment the corporate IT services from the OT services. And so you can actually, you'll find yourself with a dedicated channel of channels to use for MulteFire, which will mean that the performance of MulteFire is basically the same as the performance of LTE.
Any other questions? Excellent. Neville, thank you so much.
Thank you.
Appreciate it.